Okay. So, if you can put things in formulas, this chapter should be fine. Okay, so this is the law of sines. Now, in this section, you do have to remember we are not going to be working with right triangles, so you can't use the Pythagorean theorem. So this is an oblique. You need to know the definitions. An oblique triangle does not contain a right angle. So I'll make a note here. Can't use a squared plus b squared equals c squared. Okay, the Pythagorean theorem. You can't use that in this section. So that's probably going to be a common mistake, right? Using that. So here's the law of sines. If the law of sines is a over sine. Okay, I need to draw the triangle, I guess. But they have it. I'll draw it here. If this is a triangle, and I'm trying to draw it without a right angle, but it looks like it has a right angle. It doesn't. This is not 90 degrees, okay. The capital A is the angle and the small a is the side opposite. Capital B is the angle, small b is the side opposite, capital C is the angle, small c is the side opposite. Okay, because I drew it I'm too used to drawing right triangles. Okay. All right. And this is a law of sines. And it's the side opposite the sine of this angle equals the side opposite the sine of this angle equals the side opposite over the sine of this angle. Okay, so that's the law of sines. So you can't use this. So what you'll have to have one set and then another. You'll have to know one of these fractions, and then if you know one of these, you can find the other things. Okay, that's the law of sines. So the law of sines can be used to solve a triangle with the following known measurement. One side and two angles. Or we write it it could be a side angle and angle side angle. So a side and two angles known. So side angle is a side and two angles known. And angle, side angle means two angles with the side in between known. Okay, so we can use the law of sines when we have those two cases. All right, and I'm going to show the book if you're done. I'm waiting for people to finish copying. So, so I went in before I printed this document and gave myself more spaces. Let's see. The book is here. Okay. I just wanted to show you the book. Okay. So, oh, we don't need this part. How do you get rid of this part? Take this away.
That errors. I saw that there.
I thought there was a way, but...
Oh, I found it. Maybe. Yeah.
Is it this? Is this little thing? Double
yeah, you
arrow?
drag it. Maybe you drag it to the left. There.
Oh, there it is. Okay. Okay, so they actually go through and here they drew the oblique. So these are the two types of oblique triangles. You can have all three acute angles, and they did a better job drawing it, so it didn't look like a 90 degrees. And or you can have one obtuse angle, and then the other two have to be acute. So you got to remember too that all these new words. You still need to remember obtuse means it's more than 90 degrees. Acute means it's less than 90 degrees. So here it says, again, the book is telling you, do not apply the relationships for right triangles to oblique triangles. Don't use the Pythagorean theorem to find the missing side. And then here's another thing, the hint they tell you, do I have to write the law of sines with the signs in the denominator? No, you can flip them all. So if it's better to work with it, it's easier to solve if your unknown's in the top left, so you can flip these things. As long as you flip them all. Okay? So this book is really good. Does your book have this blue on it, Daniel, too?
Or it should, yeah, it does.
Oh, okay. So I'm not even, this isn't the teacher's edition, just a regular book. So we're going to solve a triangle now. They're proving the law of sines, but you can look at that if you want. We're not going to cover it. Next page. Let's see. Oh, I think it's there. I click there, it goes to the next page, maybe? Yeah. Okay. Okay, so there's the proof of it. And here's an example. It's a different example, so if you need to look at different examples. And here's another thing the book says. It just tells you a lot of good, helpful hints that I try to look at and make sure I tell you in class. But okay. But I did tell you this. Where did it say that? That you needed one ratio. When we use the law of sines, we must be given one of the three ratios. Otherwise, you can't use that law. So you have to be given one of the three ratios. And so this is another example, and you can look at that. But what we've solved is, so they solved this, cross multiplying or multiplying by sine 46. Okay, and then the next page, so you must be given one of the three ratios to use this. And then we're going to work this checkpoint 1. That's what's on our note. So these checkpoints are in the book and they have the answers in the back. But it's just a good way to learn to make sure you understand the material. But we're actually going to solve that checkpoint. So, all right. So we've got a side angle example here. So it's always a good idea to draw a picture. I'll try to draw one that, I don't know, they all look like 90 degrees up here. But anyway, this is going to be the 82 degrees. This is capital C, small c. I guess I'm writing A here and B here. As long as you make the small a across from the capital A angle. Okay, so and what is C is 82 and A is 64 degrees. And we've got a side known of 14 centimeters. So we got side angle. So the first thing you do is remember that the interior angles of a triangle add up to what?
180.
Right. Okay, so you're going to find angle B. Angle B is going to be 180 degrees minus the sum of the other two angles. And that was 146. And so B is 34 degrees. Okay. Now that we got all the angles, now we can find the remaining sides. Our known ratio is going to be 14 over, our known ratio is C over sine C. That's going to be 14 over sine 82. So we can find the other sides. I can find side A, because A over sine A, which is 64 degrees, equals this. So now you're solving for A. So you can either cross multiply, or if you have this in the upper left, you would multiply through by sine 64 degrees. Either way, I think I'm sine 64. So you can cross multiply and get it, or you can, if you have this in the upper left corner, you simply multiply. You're multiplying both sides by the same thing. And so this is what A is. So you got to do that on your calculator.
Just make sure it's in degrees.
Yes, exactly. So your calculator has to be in degree mode. If your calculator is not in degree mode, you're going to get the wrong answer. So we've got 14 times sine. Oh, I forgot to check. Okay, well I can just go check now. Mode, and it's in degree. Okay, I didn't know for sure, but it's in degree already. Second quit. So I'm in degree mode. I'm okay. 64. Sine of 64 degrees divided by sine of 82. And they just want us to round to one decimal place? Yeah, round to nearest 10. Yeah. So we get 12.7. And that's in centimeters. So 12.7 centimeters. Okay, we can find side B. It's B over the sine of the angle B, which is 34 degrees, equals, and we may as well just use the original known side that we have. And so that if we made a mistake on the calculation per A, we won't quadruple it. Okay. So we're going to use 14 sine 82 degrees. Did I make a mistake?
Yeah, you did sine 64 instead of 46.
It's B over...
No, that's... Oh my gosh, I did it wrong. That's my fault.
Oh, okay.
I put 46 instead of 64.
Well, that's easy to do.
I do that.
Okay. Yeah, I've got... That's why I worked it out before class, but sometimes I forget to look. So, no, that he made a mistake, I didn't. Okay, so I got A is 12.7. And so now you can multiply through by sine of 34. So B is going to be that whole thing. Now, it doesn't hurt to put extra parentheses in, but I knew that it was going to do the sine before it divided by. So I knew I didn't need parentheses there. But if you're not sure, you can put the parentheses. You know, so it's 14. If you want, you can put the parentheses. Sine 34. But you do have to close that parenthesis. And now that since I put an extra parenthesis, I've got to close that one. And then divided by, and you know, you can put parentheses if you want, but sine 82. But you can work with your calculator. See, I didn't need all those extra parentheses. I put a bunch of them. If you want to do that, you can, but you got to be careful with those too. Because the calculator will do the sine operation before it divides. So, or that's all together. So 7.9 centimeters. Okay, so that is knowing how to put it in your calculator and following the instructions. So, oh, I got on B, example B. You guys done? Copy? Okay, so example B, which I put on the next page to give you room. Okay. All right, so we'll keep going. But draw a picture. We've got 40 degree and a 22 degree, 22.5. So, you know, this picture. A, B, C, no, B, I'm looking at the wrong picture, C. B, A is 40, and C is 22.5, and so B has to be the obtuse angle. So again, we're going to find your angle B first. It's going to be 180 minus the sum of the other two. And if you do that calculation, you get 117.5. You just put that in your calculator, or as is with parentheses, or add this first and subtract from 180. Okay, inside small b is 12, small a and small c. So again, now we need, this is angle side angle. It's really solved the same way. We find the missing, since we have two angles, we find your missing angle. And now you're going to find your missing sides. You're going to use the known ratio. And we're looking for sides, so our known ratio is B over sine B, which is 12 over sine 117. We're going to set that equal to A over sine of A. 40 degrees. We're going to multiply through by sine of 40. So our A is going to be 12 sine 40 degrees divided by sine 117.5 degrees. Sine 40 divided, I got to close the parentheses though. So, on your calculator, if you don't close this parenthesis, it opens the parenthesis up, you've got to close it. Otherwise, it thinks you're still in the sign. And then divide by sine of 117.5. And you don't have to close that parenthesis, but you can select it. Because when you hit enter, it closes it. Alright, and that's about 8.7. And they didn't give units on this one, so A is approximately 8.7. Now we need to find C. Oh, we'll box in our answer. Okay. So now we want to find C. So it's going to be C over sine of C, sine of 22.5 degrees, equals our, well, it doesn't matter which one you use, I'm going to continue to use B over sine. 12 over sine 117.5 degrees. Just in case, if I made a mistake here, it won't carry through to that one, that way. Alright, and then I'm going to multiply by sine 22.5 degrees. And put that in the calculator. Maybe I can, I don't know if this is going to help, but It's gonna be 12 sine 22.5. This is a word processor, but 22, and then second insert 0.5 divided by sine 117. Oh yeah, I did say some steps. Okay. I recalled my last entry, second enter, and I went in and edited and put in sine 22.5. I've got it right. Hit enter, and it's about 5.2. Okay, so that's that. Let's see. That's the first page. All right. Okay, when we are given two sides and one angle opposite one of the sides, that'll be the side angle. There may be one, two, or no triangles that fit the measurement. Let's get rid of the calculator. This is called the ambiguous case. Let me show you the picture of the book. So I just filled in an ambiguous case. So we got to go to where we are in the book now. So these notes are basically doing the checkpoints for you. Oh, I even wrote the page number. Show picture, page 685. Oh, that's it. So there's probably a slide with this on it, but here it is in the book. You can have one triangle. You can have one right triangle, one oblique. You can have no triangle if A is less than H, is not long enough to form a triangle. Or you could have two triangles, one like this and one like that, if A is greater than H and A is less than B. So this is a side-side angle, and we don't have to draw an accurate sketch, but the law of sines will determine the number of triangles, if any, is the solution for each triangle. So here's an example. We're not doing that one. We're going to do the this is probably the checkpoint that we're doing. But checkpoint 3. Oh no. Anyway, I don't remember where this one was in this book. What we're going to do. Okay. So this is actually a case where there's this one. When we solve it, we're going to find out there's no triangle. So we're showing the no triangle case first, and the book didn't do that. So we have A sine A equals B sine B. And you've got, filling in that, you've got 10 over sine 50 degrees equals 20 over sine B. And if you want, we could flip these. Might have made it easier, but I went ahead and cross multiplied. If you have a fraction equals a fraction, you can cross multiply. You can't cross multiply if you don't have a fraction equals a fraction, or if you don't have an equal sign. But So it's 10 sine B equals 20 sine 50 degrees. Divide by 10. So we have sine B equals 2 sine 50 degrees. And we'll write that to 4 decimal places. Now I've already done that, but sine 2 times sine of 50. And it's in degree mode. 1.5321. Now, here's what does the answer to sine of an angle have to be between? -1 and 1. So you can't have a sine of 1.5, so there's no solution. So there's no triangle. So you do need to write no solution, and go ahead and write no triangle. So that's a no triangle case. You'll end up with an impossible value of sine. Okay? Okay, this next example is 2 triangles. So there was not enough room. I tried to make more room, but I probably didn't give myself enough. But okay. This is 2 triangles. This is on page 688. It may be the checkpoint though.
Yeah, it's checkpoint.
It's a checkpoint, so it's not actually work. But before that, there's another example, work. If you have trouble with these, look at the example. So, on this one, where's the known side is, so 12 over sine of 35 degrees is the known side. And that equals, so A over sine capital A, B over sine B. So we're going to solve this and find B. I'm going to cross multiply. If you don't like cross multiplying, you could have written this, flip both these and multiply through. But cross multiply, you get 12 sine B equals 16 sine 35, and you can divide by 12. So sine B equals that, and you're going to find that in the calculator. If I do that in the calculator, I got sine B was 0.7648. All right, so 0.7648. So remember, this is positive, so where is sine positive? Which quadrants? 1 and 2. So we're going to take the inverse sine. So, and get V1. Oh, I'm sorry to write inverse sine out, but sine inverse sine of 0.7648. Second, sine inverse, 0.7648. And it did say to the angles to the nearest degree. So we're just going to let it be about 50 degrees. Okay, but now you do have to remember that sine is positive in both quadrants 1 and 2. And if you have an angle of 50 degrees here, your other angle, your reference triangle is against the x-axis, so this is 50. So your other angle, let's do another color, it goes from here to here. B2. All right, maybe you can't see. So you take 180 minus 50 to find that. Oh, well, let me do B2 over here. 180 minus 50. Did I do that right? Oh, okay. And, oh, I'm looking at the, it's 150. I'm looking at the part C. 130. Okay. So we have a possible triangle with 50 degrees, and then we have another possibility at 130. So, and the angles, this leaves, if this angle was too big and it added together with this and was more than 180, then there wouldn't be a second triangle. And that's what you're going to see in the next example. So we've got two triangles. So we're going to have one that looks like this, and one that looks like, oh, this must be B2, sorry. And the other one should be all a cube. I can't ever draw these letters. Okay, but it's that we're moving this side, which is its side A, is moving. Is what happens. Okay, so this is not the answer, this is just, they want us to find, they want us to solve the triangle. We find all the missing sides, all the missing angles. So once we find B1, we have to find, okay, we're given A and B, we can find C1, or C, yeah, C1. C1 is going to be 180 minus 50 plus 35. So I told you the time. C1 is capital. Wait a minute. B1. Oh, capital C1 is 95 degrees. 50 plus 35 is 85, and then 95. Now, it's important. This is capital C. The C's are kind of hard to tell if these are capital. Now we're missing, we have all the angles for this first triangle. Now we need side C. So we're going to use the law of sine. This is our known side. So we're going to have C over sine of C, which is 95 degrees, equals the known, this was A over sine of A. And we don't just take sine of 35 and round it to 4 decimal places and place it here. We're going to find, we'll have rounding errors that way. That's why I'm keeping all these in here. And then multiply it through by sine of 95. Okay, so you get 12 times sine of 95 divided by sine of 35. 20.8. So small c1, that's a small letter, is 20.8. So that's the first triangle. The second triangle has a B2 of 130. So we find C2 by 180 minus 130 plus the 35. Let's get the calculator. And when you do that, you get 15 degrees. Now you're going to find side C2, small c2, over sine of 15 equals the known ratio 12 over sine 35. You're going to multiply through by sine 15. And do that, and you should get, make sure you get it, but you should get small c2 equals 5.4. So those are your two triangles. You're going to have to, box in your answers and label things as with subscripts 1 and 2, and they're two triangles. So I know what you're doing. Okay? All right, and then this next one, there's just one triangle. So if A is 43 degrees, side A is 81 and side B is 62. What's the known ratio? The known ratio is 81 over sine 43. And what's the only, and then we know side B, so that's 62 over sine capital B. We're going to cross multiply, or we could have, it's 81 cross multiply sine B equals 62 sine 43. Divide by 81. So sine B, if you put that in your calculator, you should get that to 4 decimal places, part 2, that it's 0.5220. So I don't need to keep the zeros. So you always have to have a known ratio . All right. So take sine inverse. And we can double check that it's 62 sine 43 close the parentheses, divide by 81. Yeah, okay. And I could do second sign inverse. I could keep all those places by second inverse. But anyway, when I did that, and they wanted to the nearest degree, I got B1 was, to the nearest degree, it's 31 degrees. It's not very accurate, but nearest degree. B equals 31 degrees approximately. We can write that that's B1, and we can see if there's a B2. So let's check to see, is there a B2? That would be 180 minus the sum of, what am I? Oh, 180 minus 31.
I have a question.
Yeah.
So if we got like 31.5, we round up, we round down, or is it because it's just the 31.46?
It's because it's 31.46.
Okay, I just rounded it. So I'll have to go back there.
Okay, so because it came out as 0.4,
But if it comes out as 0.5, I
it
should round
becomes,
up.
yeah, so you rounded
Okay.
twice.
Yeah.
So that's why you got 32. So
You know, the book tells you how to do, find out how many triangles are in it.
yeah, okay, yeah, that's right. So the book tells you how to, right, where's that at?
It shows you how to find H. It's B sine of A.
You know what is that? So yeah, the book is really good. So we're
Go back page. Right there.
so how does it?
You do B sine of A to get your H, and if A is greater than H, and A is greater than B, you have one triangle.
Oh yeah, that's very useful. There we go. Okay, good. So if you H, the height is going to be B times sine of A, and if A is smaller than that, there should be no triangle, etc. So if A is greater than 8, so this is an important picture, plus the words it says there. All right. Okay, so we take 180 minus 31, and we get 149, sorry, for B2, 149 degrees. So remember, we've got 31 degrees here. The reference angle would be over here for sine, positive 31 degrees. So the actual angle would be 180 minus 31, or 149. So you still need your reference angle. Still need to understand that. So, but if we have 149 degrees, if we add up the angles, then we got it. $149 plus 43 is greater than 180. So we don't have a second triangle. Or use Christian's method. What? A times sine?
B sine of A.
B sine of A.
So 62 sine of 43.
62 sine 43. And if that's You have to look at the instructions, but what is,
It's 42.3, let's say.
it's 42.3
Your A is greater than that,
because,
and your A is greater than your B, so there's only going to be one triangle.
oh, okay, so it's the instructions on that sheet say that, but also you can tell because it doesn't add up to 180. Okay. All right, so now we're not done. We got to find side C. Oh, we got to find angle C. So we don't have a B2. We just have a B and a C. Now I can call it C1, but it's really just is 180 minus the sum of the 43 plus the 31. And you get 106. 106. And then we need to find, there really was not enough room in the notes for all this. Now you need to find side C. So side C or C1, you can start calling it just C if you want. Over sine of 106 equals the known ratio that we had up here, 81 over sine 43, and multiply that by sine 106. So if you do that in your calculator, I got 114.2. Let's see. You do 81 times sine of 106, close the parentheses, divided by sine of 43. 114.2. Okay, so are you done copying? Sorry, are you done? People still copying? 114. No, that's not degrees. That is a side. So be careful of that. Okay. The degrees, C1, B1. Box in your answer. Side C1. Try to make your side smaller. It's not degrees. Those are the missing sides and angles. It just forms one triangle. Okay. Ready? All right. The area of an oblique triangle we can find with this formula. The area of an oblique triangle, let's get that calculator out of the way, is 1/2 BC sine A. Or, it depends what you're given. Or 1/2 AB, the sine of the angle between them. It's 1/2 the two sides with the times the sine of the angle between them. Okay? Remember these little side B is opposite capital B angle. So So if we have, side angle side, that's what we can find the area. So you find, and if you don't have side angle side, you can find that with the methods we just found. Okay, find the area of the triangle below. We've got 8, 35 degrees. So these are the two sides with the angle between them. So it is probably easier just to remember that this is the angle between them. So the area is 1/2 the two sides multiplied together, and they're in meters, so we're going to get square meters, times the sine of 135 degrees. 4 times 12, that's 48. You get 48 sine 135. So, if they want you to, it came out to almost exact, 34, exact, it's 33.9 meters squared. It didn't tell me what to round to. I'll try to remember to tell you what to round to, but it's about 34 meters squared. All right, and then we have an application problem. So that's the area. That's not too bad. We've got two, now, we need to remember bearing for this. We got two fire stations. They're 13 miles apart. Fire lookout stations. With station B directly east of station A, both stations spot a fire. So this is the fire. I should do it in red, but that's the fire. The bearing of the fire from station A is north 35 degrees east. So it's 35 degrees east of north. This is the north-south line, so this angle is 35. North 35 degrees east means 35 degrees east of the north-south line. And then this one said it's north 49 degrees west. That means 49 degrees west of north. So you'll have to remember bearings for a problem like this. This is 49 degrees. So we don't know, we have to find this triangle, we have to find, we're going to call this A, we have to find A, and we have to find B. So angle A is going to be 90 minus 35. Is 55 degrees. Angle B is going to be 90 minus 49. And that's 41 degrees. So we can find angle C is 180 minus the sum of those two, 55 plus 41. And that's 84. So now we know angles A, B, and C. Should I go to the next page? Oh, yeah. Okay. All right, so now we need to find, they want to know how far is the fire from station B? Well, that's side A. We want to find side A. So A over sine of A, which is 55 degrees, equals what's our, we get to pick, I guess. I picked, this is side C. It doesn't matter. Oh, we know C is 13. Okay. Well, we have to pick side C over sine C. 13 over sine of 84. And then multiply through by sine 55. And we only got through, so we'll multiply that out and you get 11 miles, approximately. I got 10.7. It's in miles, or if they said to the nearest mile, no, the nearest tenth. Oh, they did say the nearest tenth. All right, we only made it to law of sine. So if I'll look at that Chovy sheet, if it's law of cosine 2, you won't have to do it for Monday, but I'll look at it.
I don't think it's due till Thursday.
Oh, it's not due till Thursday. Okay, thank you. All right, have a good day, you guys.